Hello everyone, welcome to Skilled Dev. Trey here, and in this lesson, we're going to implement a queue from scratch. The constraints on our queue is that it needs to be implemented with a linked list. The methods are peek, enqueue, and dequeue. All operations should be done in O of 1 constant time, and this works perfectly with the linked list. And what we're going to do is have a pointer at the first item and the last item. So that way we're getting constant time operations on the ends, because we're just updating pointers to add and remove items. And finally, our queue needs to be a FIFO queue. This is the fundamental concept of a queue. The first items added will be the first items removed. So it's just like a line or a queue that you think of in real life. People stand in line, and the first person that got there is going to be the first person helped. And now, let's visualize our queue. Our queue is built with a linked list, and the linked list nodes start at the front where we have a pointer from the queue that points at the first node, and each linked list node points to the following item in the queue, which we indicate with the prev pointer. So the first node points to the second node to the third, and then so on until the last node points to null. We also maintain a queue.last pointer, so we have a pointer for the front and the back. We use the first pointer, the front pointer, for removing items because it operates in FIFO order. So the first one added, it becomes the first one removed. And when we add new items, they're added to the back. So we update this last pointer when we get a new item added to the end. The first method we're going to implement is queue.peek. And what peek does is it just returns the first item. Because we're operating in FIFO order, peek peeks at the top, which is first. And notice that we only return the item. We're not changing or updating the queue, we're just returning the node in the first spot. The next method we're going to implement is queue.enqueue, which adds a new item. Here, we create a new linked list node, new node 17, and now we call queue.enqueue item. So we add the node to the end of the linked list, and then we update queue.last, its pre-pointer, to point to this new node. Now we update queue.last to point to the new last item. And now we've successfully added a new node to our queue. To remove an item from the queue, we call queue.dequeue, which removes the first item. So we remove it and return it to our user, and then we update queue.first to point to the item that was behind it, or the previous queue.first.prev. And now we're ready to implement our queue. Our queue is going to be implemented with a linked list, so we're just going to define a linked list as an object with the data attribute, which is going to be the value of that linked list node, and then a prev pointer, which will point to the following item in the queue. Our queue will have three methods: peek, enqueue, and dequeue, and then once we implement this, we'll run an example below. First, let's just initialize our first and our last pointers, and this is how we maintain a reference to the front and the back of the queue. Our peek method is what allows us to view the top item in the queue, or that first item, and all we do is return the first item, so simply return this .first. When we add an item, we add it to the end. So this is going to be the new last item, or the new last node. So we'll call it new last node equals new linked list node of the item. And the item is just the value we want to store in that node. We also want to check if our linked list is empty. So we'll say not first and not last. We could just check if it's either not the first that exists or not the last that exists, but we'll explicitly check both to prove that we don't have any items in the queue. And the reason we care if the queue is empty is because when you add that first item, it is the first and the last item simultaneously. So if is empty list, we know we have 0 items. We'll set our new last node to be the first item and the last item. If our queue is not empty, if there's one or more items, well then this new item just becomes the last node. So what we do is we take the item that's currently stored in the last node using this last pointer, and we set its prev to be the new last node. So now we're just maintaining that linked list chain. Once we have that, we can now update this .last to point at the new last node. And finally, just for a reference, we'll return the node that we created. So to walk through it, we created a new linked list node, and we check if the linked list is empty, or if their queue is empty. If it is empty, the item we add is both the first item and the last item. If it's not, well, we just continue our linked list chain by setting the item that's currently the last item, setting its pre-pointer to the new last node, and then updating this .last to reference the new last item. The dequeue method is what allows us to remove items from the queue. And we always remove the first item. So we initialize our removed item to be this .first. And then if removed item is null, so if there weren't any items in the queue, then we just return null because no items were removed. Now we want to see if there's only one item in the queue. If there's one item, then we must update the last pointer to also be null because it's going to be removed. So if has only one item, and that's when the first pointer is equal to the last pointer. And the reason we only update last to be null is because below, when we update the first pointer, well, if the removed item is the only item, its prev is going to point to null, so it will already be set to null in that case. So we could explicitly set first null here, or it will be handled when we set removed item dot prev to the first pointer. And finally, when we remove an item, we will just return that removed item to our user. So to walk through it, we initialize this removed item, we check if the removed item existed, and if it does not exist, if it's null, then we just return null. Then we check if there's only one item in the queue. If there is only one item, we must also update our last pointer to be null because they're both pointing to the same item. Then we set this .first to be the second item in the queue by taking removed item.prev and setting it to this .first. If there's only one item in the queue, this .first is going to be set to null because removed item.prev is null. And finally, we return removed item. And now let's walk through an example. We're going to view our queue as a line in real life. Customers will line up and then be helped. So let's initialize our queue and say const line equals new queue. Then 3 people line up. Elon, Steve, and Bill. So we enqueue all 3 people. When we console log this in a moment, we'll see that Elon should be first, Steve should be second, and Bill should be last. This .first will point to Elon, and this .last will point to Bill. Then when Elon is going to be helped, we call line.dequeue. This means first should now point to Steve, and Elon should be removed from our queue. Then 3 more people show up, Mark, Jack, and Jeff. And then 2 are removed, so Bill and Steve will no longer be in line. So let's check. Elon is first in line and Bill is last in line. Then Elon is helped, so Steve becomes the new first person and Bill is still at the end. We add 3 more people and Jeff is the last person, and then 2 are helped, and finally Mark is in front and Jeff is last. And there it is. Now we have a fully working queue implemented from scratch. I hope this gave you the fundamental understanding of queues and how they're operating underneath the hood. Thanks, and I'll see you in the next lesson.